Hi, I'm Andrew Mills, and this is my Physics 2211 Lab 1 Constant Velocity. The goal of this lab is to use a video's data from Tracker to observe the motion of an object moving in one dimension. Then build a computational model using Newton's second law, and finally compare the model to the measured data. My main result was that the object's x position increases nearly linearly with time, and the x velocity stays approximately constant. Because the velocity is constant, the best physics model is the zero net force model, which produces a predicted x of t that matches the observed x of t as well. The system I analyzed is a moving cart on a track. The surroundings are the track and the earth. In Tracker, I defined the coordinate axes so that the x-axis is along the track, and I track the object's position frame by frame using reference marks along the ruler or meter stick visible in the video. The data I extracted is the table of time t in seconds and position x in centimeters. For the computational model, I used the momentum principle, which is equivalent to Newton's second law. And momentum is P equals mv. If the net force is zero, then momentum doesn't change, meaning velocity stays constant. So, my model assumes the cart experiences negligible net force in the x direction, producing constant velocity. My initial conditions come from the observed data. At t equals 0, the position x of 0 equals 0. To estimate velocity, I use the slope of the x versus t graph, or delta x over delta t. The motion goes from 0 centimeters to 72.1 centimeters over 0.833 seconds, which gives me a velocity around 86 centimeters per second. So I set the model's initial velocity to exactly 86.55 centimeters per second. In GlowScript, I updated position with x new equals x old plus v delta t, because velocity is constant in this model. Also added the observed data arrays from Tracker and plotted them as red curves. Then I computed observed velocity using the equation shown here and plotted that on the same velocity graph. So the graph shows green equals predicted and red equals observed for position. When I compare the curves, the observed x of t points lie very close to the predicted x of t line. That means constant velocity is a good approximation. For velocity, the observed v of t fluctuates slightly around a constant value. Those fluctuations are expected because the video tracking introduces small measurement errors by me. But overall, the trend supports a nearly constant velocity. The source of error is just me unable to perfectly click the middle of the cart each time. If I flip the axes so that positive x and negative x were interchanged, the positions would become negative compared to the original coordinate system, and the velocity would also change signs. But the motion would still be a constant velocity. The graph shape would be the same, just reflected across the horizontal axis. The physics conclusion that the net force is approximately 0 would not change. When the net force is 0, it does not mean there are no forces. It means that the forces balance. In my setup, there are multiple forces: gravity downwards, the normal force upwards, and possibly friction or air resistance opposing motion. In the x direction, any friction is small and there is no sustained push during the track interval, so the force in the x approximately sums to 0. That's why the velocity stays nearly constant. In conclusion, the Tracker observations show constant velocity motion, and a zero net force momentum principle model reproduces the observed position as well. Thanks for watching.